Alright, starting a pass for Kilarney even, not Kilcarney. Let's get that video back. So yeah, if you've got a really low western horizon, looking at 10 past 10, just pokes its head up. Let's get the ball rolling. So yeah, it's got a decent maximum altitude for the pass, it looks like. Oh, slow things down. So the range is dropping below probably 300 kilometres in total. So if you've got binoculars or a decent camera, there's a really good chance you're going to capture these solar panel colours. I would have thought. So yeah, that's well. So it's roughly the same altitude as the moon at 12 minutes past and 15 seconds, again according to my jinky calculations. And then it's going to be passing roughly over Arcturus at 13 minutes past or thereabouts. Like I say, if you can get some timings on these or any of these, you need I think it's 3 observations to start pinning an orbit down. Well, really all we're after doing is pinning it down within the orbit, i.e. seeing how fast it moves from point to point to tell whether how close to periapse or apoapse it is. Probably won't be accurate enough observations without using a telescope or binoculars to make it really worthwhile, but it'd be interesting to compare these predictions. Satellite is visible still, and it's going to disappear very shortly. There we go, just popped into eclipse at just before 15 minutes past. Now it's notices somehow my predictions are vastly different really to Mr. Kelso, so I've got a feeling I must have made a balls up somewhere in terms of how far along the orbital track it is. Oh, gone the wrong way. No, don't do that. It escalates so quickly when you get it wrong. There we go. Slow it really down. So I'm trying to do the same again for Kelso. Oh, so it's roughly the same altitude as the moon. That's a good symmetry there to best determine if whereabouts it is on the track. So that's about 20 seconds to at 14 minutes 40 seconds thereabouts. Again, there's that little square there, and then above Jupiter you can do all sorts of measurements theoretically. But this is about 15.5 minutes past. And then getting ready to disappear. So distance is then yeah, 800 odd kilometres. No, it disappears at 17 minutes past at 20 seconds. So let me bring it back. Yeah. I was interested to see what the minimum distance is. So 246 kilometres. I mean, its orbit varies from approximately it goes up to 350 and about 215 kilometres is the closest. So it's up in a decent altitude. What is the altitude? That's 70. So I mean, you could do this with like trigonometry and shit. That sounds so intelligent. You know, ignoring the curvature of the Earth and just do a basic triangle. And then I suppose if it's within a few degrees, you could just add the curvature in manually. So if you're like 3 or 4 degrees away from a different site, you just add 3 or 4 degrees to the result, and accuracy be damned. So yeah, so its range is about 260 kilometres thereabouts is the 250, 249, 246. Yeah, 245 kilometres, so it's pretty close considering. I think that's the sum of what makes it actually be fairly bright, is the space station is, what, 350, 400 kilometres, isn't it? So with the old inverse square law, it can make a decent difference to how bright it appears. Right, well, I'm off ski.